Hi, and welcome to the fourth and final class on time and work. So far, we started with the first class where we introduced the concept of work and the number of days taken to complete the work. So if multiple people work together, then in how many days the work will get over. So that was primarily the concept that we looked at the first class. In the second class, we looked at the concept of man days and man hours. Okay, and how we can have men, women, children working with their individual efficiency known or not known to calculate the number of days required to finish the work. In the third class, we explored the concept of efficiency and how much wages should multiple people be paid if they're working together on a project. And in this class, we are going to look at the concept of pipes and cisterns. Okay, pipes and cisterns, very interesting application of the concept, where basically if you see, so far we were saying that if A can build a wall, let's say in 10 days, B can also build the same wall in 15 days. If both of them start working together, then in one day they will do 1 by 10 plus 1 by 15, which is equal to 30, 3 plus 2, 5 by 30, which is 1 by 6. They will do 1 by 6 work in a day. That means they will build the wall in 6 days. Okay. So here, if you see, the predominant concept is that B is helping A. Now let's just tweak this. And let's say A is building the wall and B now instead is breaking the wall. Okay. So A builds the wall, but B breaks the wall. Okay. So while A builds, A can build the wall in 10 days, B can break the wall in 15 days. Okay, so B is breaking the wall. Okay, so conceptually if you see, A is doing positive work, building the wall, B is doing negative work, he is breaking the wall. Okay, now both of them work together. Now the first question that comes is whether the wall will get built or not. You're starting from no wall and both of them work. Now, whether the wall will get built or not depends on who is more powerful or who is more efficient. Okay, so if you see, A can build 1 by 10 wall in a day, 1 by 10 or 10% of the wall in a day, right? B can break 1 by 15 or 1 by 15 is 6.33% of the wall in a day. So net if you see, 10% minus 6.33%, net if both of them work together, 3.33%. Sorry, this is 6.67. 6.67. So 3.33% of the wall will get built, and because this is positive, that means wall will get built every day, much lesser than what A would have done because B is breaking a lot of it. Okay, so because A is more powerful or A is more efficient. A is more efficient, that we discussed in the last class, right? 1:10 and 1:15. Who is more efficient? You multiply them by 30, you get 3:2. So clearly A is more efficient. Now because A is more efficient, the wall will get built. If B was more efficient, the wall will never get built. Okay, so first it comes to the concept of who is more powerful. And clearly here A is more powerful. We can do from here also, from the fractions, 1 by 10 minus 1 by 15 will give you 30, 3 minus 2. Now you'll get 1 by 30. So whether you take 1 by 30 from reciprocal or you take 3.33% from percentage, both are same, but net because we are getting a positive value, that means at the end of day one some positive work has happened. So some wall has got built, much lower than what A would have built himself, but wall has got built. So finally the wall will get built. How many days will that take? Now you can see here clearly the answer. In one day, 1 by 30 of the wall get built. So it will take 30 days for the wall to get built. So here, because B is doing negative work, the days required are much more because A builds 10%, B breaks 6.67%, only 3.33% remains at the end of the day. Okay, so in 30 days, the wall will get built. So this is a classic example of negative work. Okay, and I'm sure a lot of people in your circle also would be doing negative work. You do something, they destroy. Okay, so finally what happens depends on who is more powerful or who is more efficient. Okay, now this concept applies very easily in a pipes and cistern case, because there what we assume, you typically have a cistern. Now cistern is nothing but a tank. So you have a tank which has multiple taps connected. Okay, so you have tap A, you have tap B, and you have tap C, let's say. Now tap A is a filling tap. That means it puts water in the tank. Tap B is a filling tap. It puts water in the tank. But tap C is an emptying tap. It takes water out of the tank. So exactly same. A is doing positive work, B is doing positive work, and C is doing negative work. Okay, so solving wise nothing changes. Whatever is doing negative work, for that the work done you take with a negative symbol. That's all. Okay, and finally positive work will get done or negative work will get done. That depends on the combined efficiency of all the filling taps versus combined efficiency of all the emptying taps. Whosoever is more efficient will decide what is the work that will happen, positive or negative, positive or negative. Okay. Okay, so I hope we have understood this piece. Now let's apply this to a couple of questions and see. Okay, so let's start with a very simple question. A can fill 4 liters per minute. So A is 4 liters per minute. Okay, this is already given per minute. Not normally our data is it can complete the work in so much time. That is not given. We are saying that A can fill 4 liters per minute. So plus 4 per minute. While B can fill 5 liters per minute. Both of them are positive. So B is plus 5 per minute. So when they work together, A plus B, then they can fill obviously 4 plus 5, 9 liters per minute. Okay. Now the tank is of a capacity of 135 liters. So to fill 135 liters, if I am filling 9 liters per minute, I need 15 minutes. Okay. So the answer is very simple, 15 minutes. Okay, fine. Now let's change this question a bit. Let's say B can empty 5 liters per minute. Now if B can empty 5 liters per minute, now for B you will take minus, net work will be A plus B. When A and B are working together, it will be minus 1 liter per minute. Right? So this tank, you will see if it's an empty tank, it will never get filled, because in 1 minute A will fill 4, B will take out 5. So actually it will remain empty forever. But let's change this also. Let's say this is a full tank. We start with a full tank. And then the question is, both the taps are open together, both the pipes are open together. Then in how many minutes will the full tank become empty? Okay. So now you can see that when A and B work together, they reduce 1 liter in a minute. So to reduce 135 liters at the rate of 1 liter a minute, I need 135 minutes. So the answer would be the full tank can be emptied in 135 minutes. Because every minute A will fill 4, B will take out 5. That means net 1 will get taken out, 1 liter per minute. So for 135 liters, you need 135 minutes. Okay. So that's how both sides can be solved. Very simple. Okay, you just have to be clear of your positive and negative. Okay, let's look at slightly better question. An empty tank is connected to pipes A, B, C. A and B are inlet pipes and they fill in 5 minutes, 4 minutes. C is the outlet pipe. It empties in 8 minutes. So now it is not per minute, but it is total time taken. Okay, so this is our standard method that we were doing earlier. So A, B, C. A can fill in 5 minutes, B can fill in 4 minutes, C can empty in 8 minutes. So empty you will have to take with a minus sign. And one small change you will notice that earlier most of the questions we were doing in days. Here the questions are in minutes. Okay, so normally in pipes and cisterns the data will be in minutes or hours, not days, because you don't take days to fill a tank, right? Okay, so very simple. So in a minute, the work done will be 1 by 5 plus 1 by 4 minus 1 by 8. Okay, because all the pipes are opened simultaneously. So in fact 5, 4, 8, the LCM will be 40. So let's take 40. So you have 8 plus 10 minus 5. That is what we get. So 10 plus 8 is 18. 18 minus 5 is 13. 13 by 40. Okay, so time taken will be 40 by 13 minutes or 3 1 by 13 minutes. It will get filled in so much time because it will get filled because this is more powerful than this, right? If you want to compare the efficiency of the filling pipes versus the emptying pipes, filling pipes are 1 by 4, 1 by 5 plus 1 by 4, which is 20, 4 plus 5, 9 by 20. So 9 by 20 versus 1:8. Okay, if I multiply both by 40, so you'll get 18:5. So the filling pipes are much more powerful. So obviously it will get filled. Now imagine that if this emptying tap was not there, then how much time it would have taken to fill? 1 by 5 plus 1 by 4, that's all, which is 9 by 20. Okay, if only A and B, this is the answer when A, B, C, all three of them were working. If only A and B were working, then time taken should be lesser because B had done some negative work. So it has increased the work for A and B. So in fact, then it would have been 9 by 20 or 20 by 9, which means 2 by 9 minutes. It would have got filled only in 2 by 9 minutes if A and B were working. But that became this much because C is emptying also simultaneously. Okay, so very simple concept. Basically for the emptying pipe, you take its value with a negative sign, that's all. And net, if you get a positive value, that means positive work is happening. Net, if you get negative value, that means negative work is happening. Fine. Okay. So let's look at this second question on pipes and cisterns, slightly more complicated. So see this carefully. So we have here pipe A and C fill a tank while pipe B is a drain pipe. So A does positive work, B does negative work, C does positive work. Okay. Pipe B empties the full tank in 1 hour less than the time taken by A to fill the empty tank. So let's say A fills in A. So B will empty in A minus 1, and for C we will take C. Okay. When all the pipes are turned on, the empty tank is filled in 2 hours. So 1 by A minus 1 by A minus 1 because B does negative work. You'll have to be careful here. Plus 1 by C is equal to half, right? This is a simple first equation. Okay, if pipe B and C are turned on together when the tank is empty and pipe B is turned off after 1 hour, pipe C takes another 1 hour and 15 minutes to fill the emptying tap remaining. So understand this carefully. B and C both work for 1 hour. After that, C works for 1 hour and 15 minutes more. Okay, so total time that C has worked for is 2 hours and 15 minutes, right? Or 2 1 by 4 hours or 9 by 4 hours. Okay, so C has worked for this much and B has worked for 1 hour. So this will be easier to make the equation, and C is a filling type. So let's say a filling tap. So let's take C first. So we can say 9 by 4 C, right? 9 by 4 is the duration, and in every hour it does 1 by C, right? Minus B has worked for only 1 hour, so 1 by A minus 1. This is the equation, is equal to, now it takes 1 hour and 15 minutes, and so total work done is equal to 1, right? Because the tank has been filled. C has worked for 9 by 4 hours. So 9 by 4 into 1 by C minus 1 by A minus 1. Now these are two equations and we have to solve them. Okay. As you can see, C should get cancelled so that I have equation in terms of A. So let's multiply the first equation with 9 by 4. Okay. So we multiply this with 9 by 4. So that will give me, let me remove this line. So when I do that, I get 9 by 4a minus 9 by 4 a minus 1 plus 9 by 4 C is equal to 9 by 8. Okay, these are the two equations I've got. Let's multiply the first one by minus. So minus plus minus, and let's add them. Add them effectively means subtract them. So you can see that this will get cancelled. On the right hand side you have 9 by 8 minus 1, which will give you 1 by 8. And here I'll get 9 by 4a plus 1 by a minus 1 minus 9 by 4 a minus 1. Right. The second one also, let's multiply this by 4, both the numerator and the denominator. So it becomes same. So I get 9 by 4a minus 5 by 4 a minus 1 is equal to 1 by 8. This 4 and 8 can be cancelled. Instead of 8 I'll get 2. Okay, so 9 by a, let me write it here, 9 by a minus 5 by a minus 1 is equal to 1 by 2. Okay, now let's take LCM. So upon a into a minus 1 is 9a minus 1 minus 5a is equal to half. Let's cross multiply. So 9 into 2, 18a minus 18 minus 10a is equal to a square minus a. Okay, so 18a minus 10a, 8a minus 18 is a square minus a, or a square minus 9a plus 18 is 0, or a minus 3 into a minus 6 is 0. That means a is equal to 3 or a is equal to 6. Okay, so slightly complicated calculation, but that's how you do. Okay, then there's one more hint. Pipe A can fill that empty tank in less than 5 hours. That means A is less than 5. So A of 6 is rejected. A is equal to 3. Okay, so A is 3. That means B is 2, because B was A minus 1, right? So A we got as 3, B we got as 2, and obviously putting this we will get C. In fact, the question is about C. So let's put that in the first equation here. So 1 by A, which means 1 by 3, minus 1 by A minus 1, which is 1 by 2, plus 1 by C is equal to 1 by 2. Okay, so 1 by C is equal to 1 by 2 plus 1 by 2 minus 1 by 3. LCM is 6. So 6, 3 plus 3 minus 2. 3 plus 3 is 6. 6 minus 2 is 4. So 4 by 6 or 2 by 3. So 1 by C is equal to 2 by 3, or C is equal to 3 by 2. 3 by 2 hours means 90 minutes. So C can fill it in 90 minutes. That becomes my answer for this question. Okay, so slightly complicated, but if the whole essence is making these two equations, this is the first equation and this is the second equation. After that, it is solving the equations. If you can solve this, with this, you'll end up with two values of A, 3 and 6, but then there's a data ki A is less than 5, hence 6 is rejected. We go with A is 3. When you have A as 3, you get B as 2, and then C we can find out, which is 3 by 2 hours, which means 90 minutes. Okay, great. Let's solve a couple more questions, and we are taking slightly more difficult questions now. A tank has two inlet pipes A and B along with an outlet pipe C. So A, B, C. A is positive, B is positive, and C is negative. A is 100% more efficient than B, which is twice as efficient as C. Okay, so let's say C takes C hours to fill. Okay, or let's say C takes 4C hours to fill. Okay, now B is twice as efficient. C takes 4C hours to empty. It's an emptying tank tap, right? Now B is twice as efficient. So you remember, when you're twice as efficient, you'll take half the time. So B is going to take 2C time, half of 4C. And A is 100% more efficient than B. 100% more efficient again means twice as efficient as B. So it will take half the time of B. Hence it is going to take C hours. Okay, so that's why we took C as 4C, because you will avoid a fraction. Else you could also have taken this as C, this will be C by 2 and this will be C by 4. But when we have to assume, why not assume something which reduces my fraction part? Okay, so these are the number of hours they will take to fill or empty, depending on whether they are a filling pipe or an emptying pipe. Okay, then when all three are open, that empty tank gets filled in 16 hours. Okay, so 1 by C plus 1 by 2C minus 1 by 4C, minus because C is an emptying tap, is equal to 1 by 16, right? This should easily give us C. So 4C. Okay, so 4 plus 2 minus 1 is equal to 1 by 16. This will give you 4. And in the numerator, 4 plus 5, 6, 6 minus 1, 5, 5 into 4. So C is equal to 20. You get C as 20. Okay, so once we have C as 20, that means A can fill in 20 hours, B can fill in 40 hours, and C can empty in 80 hours. Okay, so, okay. Now, what percentage of the tank is filled by A in 1 hour? A can fill in 20 hours. So in 1 hour, it will obviously fill 1 by 20, which is 5%. So this answer is 5%. In how many hours C can empty half the tank? C can empty the full tank in 80 hours. So half the tank it can empty in 40 hours. Okay. And an empty tank can be filled in how many hours if only A and C are open? If A and C are open, then work done per hour is 1 by 20 minus 1 by 80, which is 80 upon 4 minus 1, which is 3 by 80. Hence time required is 80 by 3, which will give you 26 2 by 3, right? So 26 2 by 3. And if B and C are open, then 1 by 40 minus 1 by 80, or 80, 2 minus 1, which is 1 by 80. So it's going to take 80 hours. Okay, so that's how typically this gets solved. Hope we are clear with this. Okay, so we have combined the concept of efficiency also, and we have applied that in pipes and cisterns. Okay, great. Let's do one last question. Okay, and this is an interesting question. There are some inlet and outlet pipes connected to a tank such that all the pipes of the same color have the same capacity. A set of K blue pipes. So we have blue pipes, K number of them. They can fill 80% of the tank in 8 minutes. 80% of the tank in 8 minutes, that means 100% of the tank in 10 minutes. Okay, so in 10 minutes they can fill. But they're K pipes. So each pipe can fill in how much? Understand this carefully. Okay, K pipes can fill it in 10 minutes. So one pipe will fill in how much time? K pipe can fill in 10 minutes. Okay, so if you give only one pipe, then it is going to take much longer. Okay, will it be 10 K minutes? Okay, for example, let's take a value. You have 5 pipes. 5 pipes can fill in 10 minutes. Okay, so one pipe obviously is going to need 50 minutes. That will be the logic. One pipe can fill in 50 minutes. So if you give 5 pipes, the time taken will become 1/5. So if there are K pipes, that means each pipe can fill in 10 K minutes. Okay, this is the time required. Similarly, another set of M green pipes can fill 50% in 4 minutes. So green, we have M pipes. They can fill 50% in 4 minutes. That means 100% in 8 minutes. So each one of them will need 8 M minutes to fill. And third set of red pipes, which are N, they can empty. So this is negative, this is negative, this is positive, this is positive. It can empty half the tank in 10 minutes. That means full tank in 20 minutes. So it will be 20 N. Each tank will be 20 N. Okay, so this part we are clear. So we have multiple pipes and multiple pipes of different colors. We have not done anything like this so far. So this is going to be interesting. Okay, then we have some ratio also. Okay, K is to M is 2:1 and N is to K. N is to K is 4:5. Okay, so first we have 2 and 5. LCM of 2 and 5 is 10. So this 2:1, let's change it to 10:5, and 4:5, let's change it to 8:10. So I get N is to K is to M, and this we have done in ratio, right? How to combine two different ratios. So it is 8:10:5. This is the ratio. And then it also says N is equal to M plus 3. You can see N is already equal to M plus 3. N is 8, M is 5. That means these are the values. N is 8. You have 8 red pipes. K is 10. You have 10 blue pipes. And M is 5. You have 5 green pipes. That means the time taken by one blue pipe is 100 minutes, 10K. 8 into 5, this takes 40 minutes. And this takes 160 minutes. Okay, so we have all these values with us. Fine. Okay, now let's look at the questions. After this, questions would not be difficult now that we have the values. Okay, so the first question says 7 blue pipes, 3 green pipes, 4 red pipes are kept open. Then in how much time will 84% of the tank be full? Okay, so blue pipe, one pipe does 1/100 work in a minute. I have 7 pipes, so it will be 7. Okay, then green is also filling pipe. It does 1/40. But I'm taking 3 green pipes, so work done will be this. And then red is emptying pipe. It does 1/160, and I'm taking 4, so 4. So this much amount of work will be done in a minute. Okay, so I have 7/100 plus 3/40 and minus 4/160, which is again 1/40. So I can take as 1/40 only. Now 40 and 100, the LCM is 200. So 200, so 7 will become 14 plus 3, which will be 15, and minus 1, which will be 5. Okay, 15 minus 5 is 10. 10 plus 14, so 24/200. Okay, which is 12/100, which is 6/25. Sorry, 6/50. Or 3/25. Either way, whatever way you can have. Then the question is, so basically this 12/100 is a better value here, because 12/100 also means that 12% of the pipe of the tank will get filled every minute. Okay, 12/100 work is happening in a minute. Okay, because the question is saying in how much time will 84% of the tank be full. So 84% is nothing but 12% into 7, and 12% work is happening in a minute. So obviously in 7 minutes, 12% into 7, 84% work will happen. Hence the answer is 7 minutes. Right? So answer is 7 minutes. Okay, this is one method of doing this question, which we have done using fractions. There is another method which is using percentage. And if you remember earlier, we had done some questions using percentage concept. So because the question is in percentage, let's understand that approach also. So if you see K pipe, blue pipe does work in 100 minutes. It fills in 100 minutes. That means in 1 minute, it fills 1%. I can say in 1 minute it fills 1%, and there are 7 such pipes. So in 1 minute it will fill 7%. Plus green pipe, 40 minutes, 1/40 is 2.5. So in 1 minute it does 2.5% work. Okay, and I'm using 3, so 3 into 2.5. And then red is 1 by 160. Now 1 by 160 is how much as a percentage? Into 100, if you see, this is 5, this is 8. 5 by 8 is 0.0625%. Okay, this we'll discuss more in detail in percentage class as to how to find percentages, but basically this is 0.0625%, okay, and multiplied by 4. So this much amount of work will happen in a minute. So 7% plus 7.5% minus, now when you do 0.60625 into 2, that will be how much? 0.125, and again into 2 will give you 0.25. Okay. Okay. Or if you're not comfortable with that, you let it be this. Let it be 5 by 8. 5 by 8 is also fine. 5 by 8 into 4. Okay. So that will give you by 2. 5 by 2, which is 2.5%, not 0.25, 2.5% minus 2.5%. Okay. So 7% plus 7.5% is 14.5%. 14.5% minus 2.5% is 12%. So same value we have got. 12% work will happen in a minute. Hence, to do 84%, you need 7 minutes. Okay, so it can be done this way using percentages. Let's look at the second question. Okay, now the second question says, we'll solve here. If half of the red pipes are closed and half of the blue pipes are open, half of the red pipes are closed, that means half of them are open, right? So minus 4 into 1 by 160. 4 of them are open. And half of the blue pipes are open. So blue pipes are 10. Half of them are open means 5. 5 into 1 by 100. Okay. So half of the red pipes taken care, half of the blue pipes taken care, and all other pipes are kept open. That means all of green is kept open. So that is plus 5 into 1 by 40. This is what we get. Okay. So again, 5 by 100 or 5 by 100 I better take as 1 by 20 minus 1 by 40 plus 5 by 40 is 1 by 8. 1 by 8. Okay, so this, my LCM is 40. So this is 2 minus 1 plus 5. Okay, so this gives me 2 minus 1 is 1. 1 plus 5 is 6. 6 by 40. Okay, or 6 by 40. Okay, so let it be 6 by 40. So 6 by 40 work happens in a minute. Okay, so the full tank will get filled in 40 by 9 minutes. Okay, but you have to fill only 90% of the tank. Okay, so then time required will be 90% of this, 9 by 10 of this. Okay, so 9 gets cancelled, 0 gets cancelled. You need 4 minutes. So the answer for this is going to be 4 minutes. Can we do this also through percentage method? Yes, we can. Blue, how many blue pipes we had? Half of the blue pipes. So 5 blue pipes. So 5 into 1%. Blue pipes, you know, they do 1%. Okay. All the green pipes. So 5 into 2.5%. And minus 4 red pipes. 4 into 0.0625%. Right. So this much work will happen in a minute. So 5% plus 5 into 2.5, 12.5% minus 2.5%. Okay. So 12.5 minus 2.5 is 10. 10 plus 5 is 15%. Is that correct? 15%. It should be 5 into Let's just check what we have done. Half of the blue pipes are open, so blue pipes do 1%. Half of them, so 5 of them, so they'll do 5% work. That is correct. Then red, green, we have all 5 open, so 5 into 2.5, that is 12.5. Okay, that is fine. And here we have 4 into 0.0625, which is 1 by 40, which is 2.5. So this is correct. So we have 5%, 12.5 minus 2.5 is 10, 10 plus 5, 15% work happens in a minute. But this value, 15% work happens in a minute, so I have to fill 90%. So let me check, where are we getting a different value? Yeah, so 15% work happens in a minute. I have to do 90%. So that means 15% should be multiplied by 6, which will give me 90%. So it will be 6 minutes. Or another way of looking at that is 90% is total work to be done, 15% is per minute. So 19 upon 15 is 6 minutes. Hence the answer will be 6 minutes. How did we get 4 minutes here? I think there was some error that we did. If you see, yes, this was 6 by 40. But here we have written at 40 by 9. It was 40 by 6. So in 1 minute you fill 6 by 40. So total time required to fill is 40 by 6. Okay. Minutes, but I don't have to fulfill. I have to do only 90%. So into 90% or 9 by 10. This is what you'll do. So 0, 0. This will give you 2. This will give you 3. This will give you 2. So 3 into 2, 6 minutes. So this answer is 6 minutes. Okay. So that is how this will get solved. Okay. So I think we have done fair number of questions on all varieties of time and work. And if you go through the concepts and the questions that we have done, there is no question of time and work that you'll not be able to solve comfortably. Just revise everything that we have done and practice some more questions, and I can guarantee you that you can solve each and every question very, very comfortably. As promised at the start, I have given you minimum formulas. Most of them we have solved only through concepts. The only few things to remember is your M1 D1 T1 upon W1 is equal to M2 D2 T2 upon W2, which is basically your man days or man hours is a constant. That is one. Second, your efficiency is directly proportional to 1 day's work or is inversely proportional to total days taken to complete the work. I think these were only 2 very brief concepts that we had done. Okay, so that brings us to the end of time and work. And thank you so much for attending this class, and all the best. Take care. Bye-bye.